Lesson 2.8. We're going to be looking at something called literal equations. These are just equations that contain more than one variable. Up until this point, we were solving for x. We were doing inverse operations to get x by itself. Now, instead of just x and a couple of numbers, there's going to be more letters involved, more variables. So we're going to be told to isolate one of those variables. In our first example, 4m minus 3n equals 8. Our goal is to solve for m. We're going to isolate m using inverse operations. It's the same process that we have done, just with more variables. I'm going to talk this example out step by step, and I'm going to write the transformations as we go along. First thing I need to do is add 3n to both sides. That's going to eliminate it on the left. And then I find myself with 4m is equal to 3n plus 8. Now, 8 and 3n cannot be combined because they're not like terms. It just becomes an expression. One last thing to isolate m, let's divide both sides by 4. Dividing by 4 eliminates the 4 on the left, so we've isolated m. However, this is an expression that needs to have both terms divided by 4. 8 divided by 4 is 2, and 3n divided by 4 is 3/4 n. And this is your final answer. Let's try a couple more problems. In this next one, we want to solve for n. I'm sort of putting a little arrow here so that you can be reminded that that's what you're solving for. I see that there is a 6p attached to it, so I'm going to start by subtracting 6p on both sides. It will cancel on the right this time, and I'll simplify, and I have 15 minus 6p is equal to 3n. The goal is to get n by itself, so let's divide everything by 3. Now, as I'm doing this problem, I've written it the same way I wrote problem number 1, but some of you might find it easier to take this and divide each term by 3 in this manner so that you don't forget to do it to all terms. And then I'm going to get 5 is minus 2p is equal to n. And I've actually solved for n in terms of p. Each of these additional problems are going to be slightly different. In the second problem, you see that t is multiplied by the expression 8 plus 4. My goal, again, highlighting here that I'm solving for t. It's connected by multiplication, so my inverse would be division. Let's divide both sides by r plus 4. Canceling on the left, I get t is equal to 28 divided by r plus 4. And that's all there is to that one. That was a one step. M minus 2 divided by 5 equals 11n. Let's solve for m. First thing we need to do is multiply both sides by 5. Not canceling out the 5 on the left. And then we'll multiply. And we'll get 55n. In order to isolate m, I will add 2 to both sides. Simplify again. M is equal to 55n plus 2. Once again, this cannot be combined because an n term and a constant are not like terms. One more problem. A times the expression b minus 8 equals 23. I'd like to isolate b in terms of a. Once again, I see this parentheses. It's telling me that's multiplication. I will divide. Now that I divide, it will cancel the a's. I'm left with b minus 8 is equal to 23 divided by a. I now need to add 8 to both sides. Simplify one last time. B is equal to 23a plus 8. Once again, can't do any combining. These are not like terms. My goal was to isolate b. You'll sometimes see the expression solve for, in this case, solve for b in terms of a. It might have an expression like that as your goal. It might just say isolate b. And that's our literal equations solving for one of the particular variables. There's one additional step, which is what happens when there are variables on both sides, but I'll save that one for next class.